155 min stack. Design a stack that supports push, pop, top, and retrieve the minimum element in constant time. So let's see how we can design this. What we should do is, like, we are going to store the values in a list. We define a stack and we define it as a list, and we also going to store the minimum value at each point of time in min stack. Okay, and then let's do the push function. For the push function for the stack is so easy. We are going to say self.stack.append, and we append the value that we have. But for the min, what we need to do, we need to put the minimum value at each point of time, right? So let's say what we are going to do, we are going to say if the stack is empty, if there is nothing in the stack, right? So the stack is empty, so there is nothing that we need to compare with. So we are going to just self.minstack.append the value. But if the stack is not empty, or the value that we have is smaller than the value that we have in the stack, we are going to get the minimum value and append it to min stack. We are going to say self.min stack. What we are going to do, we are going to .append. We are going to get the minimum of the value that we have and the value that we have in min stack right now. So we get the minimum of one of these two numbers and we add it to the min stack. Okay, and for pop, we need to pop the value from top of the stack. So we're going to just say self.stack.pop, and that's it. It's going to pop it. And we should do the same for min stack, because the length of min stack and stack should be the same. Min stack.pop. And now for top, it says the top is get the top element of the stack. So let's get the top element. What we are going to do, we are not going to pop the value, we are going to just return the top value that we have in the stack. So we are going to self.stack. We are not going to pop it, we are going to just return the last value, and the last value that the index of last value can be shown with -1. And for returning the minimum, we are not going to pop that, we are going to just do the same for the min stack to return the minimum value, right? And that's it. So the time complexity for every single function is constant. So this one is just returning the index, this is returning the index. We have two pops, and pop is constant time complexity, and append is a constant time complexity. So the time complexity for the whole class, for the whole min stack question is going to be constant, but the space complexity is going to be linear, as we are storing the values as we add them into different stacks. So let's run this, and as you see, it works perfectly. And thank you.